Hello and welcome to question 6 on the 2016 2C paper. The distance time graph below represents a car that is overtaking a lorry on a straight road. The speed of the car is a constant during the first 2 seconds and during the final 2 seconds. And there's our graph, so you can see that's constant there. So we've got those straight bits. That just means this bit in the middle, I guess, is not a straight line. Okay, work out the average speed of the car during the 12 seconds. So speed, distance, and time. We want the speed, which means it's distance divided by time. The time was 12 seconds and the distance was 120 meters. So that gives us 10 meters per second for our average speed. Okay, part B. Use the graph to estimate the maximum speed of the car as it overtakes the lorry. So what we can see here on this graph, speed and distance, the gradient represents the speed, and therefore we want a point where the gradient is at its highest. So we're looking for a point where, there we go. That looks about good. Maybe a bit more. Don't know. Just got to play around and try and find it. Okay, I think I'm happy with that. And we draw a line. I should have probably done that with a different color. Let me just undo that and we'll go with red so it stands out. Happy with that. Okay, we're then going to find a couple of coordinates so that we can work out the gradient. So we've got one there that's at 9.8, 120. And then another coordinate down here, that looks good. It's got a 20 for a y coordinate and it's 3.6. So we're looking at the change in y divided by the change in x. So it doesn't matter which way around you do as long as you are, they're the y coordinates. Doing this bit properly, so 120 take away 20, and then 9.8 take away 3.6 gives us 100 over 6.2. Now we turn to the calculator. Divided by 6.2, so we get 16.12. So for argument's sake, I'm going to say that's 16. Okay, and then looking at the mark scheme and what we've got here, drawing a tangent at the point in the range 5 to 7 works for you. And then your answer's in the range of 15 to 18. Okay, scrolling down, part C, sketch the graph to show the speed of the car as it overtakes the lorry. So what we've got for those first 2 seconds is a constant speed. I need to probably work that out as well. So between here and here, 10 divided by 2, distance over time equals 5. So we've got 5 meters per second for 2 seconds. How am I going to draw this? 5, 10, 15, 20, 25. So 5 for 2 seconds. Let's draw that across. Like so. Then we've got our estimate for the top speed. Now our top speed is roughly, I'm going to just estimate it as 6, because look, I've drawn my tangent roughly at 6, and then things start to slow down. So that top speed is going to be at 16 there. So we'll then see it go up. I feel that needs to be a bit more of a curve. I'm going to redraw it. And then at 10 seconds, it's going to be constant. So up and then down. And then constant speed there as well. I've just assumed that's at 5. I need to double check it. I'm not too sure it is now that we've looked at that. 102, 104, 105 to 120. That's a difference of 15 divided by 2. 7.5. So actually, yeah, that height is going to be wrong. And it's going to be here that we want it constant. Oh, I've got to draw the whole thing again. we are. So I'm just going to put in there 6 and 16. You may get a different one. If you've worked out your grading, you've got a higher speed, then you're going to have a peak there. All right, looking at the mark scheme, it says initial speed at 5 and final speed between 7 and 8. So that's 1 mark. The shape of the graph is 1 mark, and then that maximum speed shown between T5 and T7 is another mark. So you can sort of follow through from your answer in part B. Okay, and that's it. That's question 6 done. Good luck for your exams. I'll see you at question 7.